Okay, for example, number 8, what we have to do is match different functions with their derivatives. And we're looking at graphs. So what I'm going to do is I'm just going to sketch them out one at a time here. And I don't even need to really do a whole lot of looking at the derivatives because I can just tell from the original function what those guys are going to look like. So the first function that we've got looks kind of like this v, like this. And we're supposed to sketch the derivative. So I'm going to do it right on this graph, okay? Well, here, the function, remember, looking at the slopes of the tangent lines, and so the function is decreasing, so the slopes are all negative until we hit here. So the slope is going to be negative. Now, is it the same values? Absolutely not. Look, the slope here is getting closer to 0. Okay, then it's more and more and more negative. So it's probably going to look something very similar to this. Okay, so these are the slopes here, and now the slopes over here are positive, and they start really high and they get closer and closer to 0. So they're going to look something like that. And so graph number 1 matches up with graph C. Okay, now let's go on to 2. So graph number 2 looks something like this. The original graph here in blue comes up, comes down, and comes back up, and comes down. Okay, so its derivative, well, the slopes here are very, very positive, and then they scale out to be 0. So here where I've got a peak, I know I'm at 0. Here where I've got a peak, I know I'm at 0. And also here where I've got a peak, I know I'm at 0. Now, it's positive, the slopes, think about the slopes of the tangent lines, the slope, I'm increasing from here to here, which means my slopes are positive, but they're getting less and less. Just like that. Now, from here to here, my slopes are negative. Okay? They're getting more and more, and they kind of calm back out, so maybe something like this. And then from here to here, my slopes are positive again. And now from here to here, my slopes themselves are all negative. So it's going to look something like that. And so this looks like 2 pairs up with letter B. Okay, so now let's draw graph 3 out. So graph number 3 looks something like this. It starts out, comes up, then comes down, up, and back up like that. Okay? And so what we need to do is figure out what its derivative looks like. Now again, we can sketch this out without having to have the actual value, the actual derivative right there. So let's erase that. So again, between here and here, we're negative, and then we hit 0. Our slopes are flat. Here, here, and here. So that means my yellow, my derivative function, must be touching at 0 at those points. Now from here to here, it's negative. So we got to be below the axis. From here to here, we're increasing, so we're positive. From here to here, we're decreasing, so we're negative. And then from here to here, we're increasing, so we're positive. So it looks like graph number 3 matches graph E. Okay, now let's look at 4. Well, 4 is the absolute value function. Just like that. Now, there is no place, the derivative doesn't exist at this cusp, okay? But it looks like the slope is negative from here to here, and it's negative at a constant rate, meaning that it's neither increasing or decreasing. So it'll be negative at a constant rate until we hit 0. And then it's positive at a constant rate after that. So it looks something like this. So remember, this is this number. Anytime I pick a number on here, that tells me the slope of the tangent line at that value. So, for example, let's say I pick this x value here. Well, then it tells me this number right here. Let's say, I don't know, I'm gonna pick some numbers out here. Let's say this was x is -2, and this was at a height of -1. Then it would tell me that f prime at -2 was equal to -1, which would mean that the slope of the tangent line right here, that slope would be -1. Okay, so that's what we're determining. So graph 4, it looks like matches up with A. Okay, and we got one more to do. Now you could go just figure out which one matches up with which, but like I said, I think it's better to sit here and walk through each of these and determine why they look the way they do. So this comes up like this, and this comes out like this. So there's our function. So our function is really close to 0 for its slopes here. Then they increase, and then they get almost vertical. So the slopes are increasing, but they're close to 0. So they're positive but close to 0. And then all of a sudden they take off. Okay. Now it looks like they probably get vertical right here, or defined. Okay. And then they decrease back down towards 0, just like that. And it looks like they're not actually defined at 0. So this will be graph number 5, and that pairs up with graph D.